Hello everyone, welcome to my session. Today I will talk about how to speed up serialization and deserialization by compile time reflection. And this is the outline of my session. Structpack is a very fast serialization library based on compile time reflection. And it will be open source soon. Before introduce the library, I'd like to show some examples of other classic serialization libraries, such as protobuf, msgpack, or boost serialization. If you serialize an object with protobuf, you need to define a protofile at first, and then generate the code, and you can use the serialization API to serialize the object to buffer. This is an example of msgpack. Here, msgpack is more simpler than protobuf because it is only need a macro. Yeah, you need define a macro here, and then you can use pack to serialize the object. Is more simpler, but this kind of serialization is intrusive because you need to define a macro in the object. And this is an example of boost serialization. This is a non-intrusive serialization. Yeah, here we write a special serialization and serialize each field one by one. I think this kind of serialization is not safe because you might miss some fields when you are writing code. Okay. Now let's look at the structpack example. Structpack is very easy to use because it is only need one line code to serialize the object or deserialize. And there is a more complex example. This example, there is a listed object. It contains a complicated object. The object contains some fundamental types: string, containers, array. No matter how complex the struct is, structpack only need one line code to serialize or deserialize. So far, I think structpack is the simplest serialization library. And these are the features of structpack. It's very easy to use because it's only need one line code to serialize or deserialize because of compile time reflection. Of course, it's very fast. It's much faster than protobuf, msgpack, or boost serialization. I will show you the benchmark result at the end of my talk. And as you can see, structpack no need macro, no intrusive. It's very clean and simple. How to achieve it? I will uncover the secret of structpack later. Before that, let's look at some classic serialization libraries data format. Okay, this is the memory layout of an integer in msgpack. The memory divided in two parts. The first part saves the type ID, and the rest part save the value. And protobuf is similar. The first part save field number and wire type, and the rest part save the value. The steps of these are the steps of classic serialization. At first, we pack type information and then pack the value and repeat it. Serialize each field. This is the steps of classic serialization. And this is the steps of deserialization. Firstly, unpack the type information. Secondly, do type check. Finally, unpack the value. Okay, so how to speed up serialization? Okay, if we don't pack the type information, what will happen? Like this. We only save the value, don't save the type information. And I think this kind of serialization will be faster. And we don't unpack type information and don't do type checking for each field. What will happen? This kind of deserialization will be much faster, right? And this is the basic idea of speed up serialization and deserialization. Actually, there is no need to serialize or deserialize type information for each field, because we can get field's metadata by compile time reflection. Now, let's look at how to serialize an object with compile time reflection. Here, there is an object dummy, and we serialize it. Structpack will reflect all fields of dummy into items, and then put the items into a lambda. Finally, serialize each items. I think the code is simple and is simple. Okay, let's look at the implementation of visit members. Here. Firstly, structpack will get member count of the object at compile time, and then utilize structure binding to unpack all fields of the object. Finally, serialize and deserialize each field. Yes, I think the code is also simple. And the key point is how to get a member count at compile time. This is the implementation of member count. Structpack utilize C++20 concepts to detect arguments count of an aggregate type. Here, I think this kind of code maybe you have seen before it in Magic Get. Yeah, the idea is similar, and there are limitations of this kind of method. There are two limitations. The first limitation is the type must be aggregate type, and the max member count is limited. We can get rid of the limitations when reflection becomes C++ standard. Hope it becomes standard. as soon as possible. Now let's look at the data format of structpack. The object, after serialize the object, the memory layout is like this. As you can see, there is no extra type information anymore, and the memory layout is compact. This kind of data format makes serialization or deserialization more efficient. But there is a problem. Structpack don't save type information of each field, but how to keep type safe when deserialized? This is a problem, right? Of course, structpack need to do type checking. However, structpack type checking is much more efficient because do type checking only one time. The basic idea is structpack encode object type fields type into a 32-bit hash code at compile time. The hash code will be used to do type checking. So these are the steps of structpack serialization. Firstly, generate hash code of the object by compile time reflection, and serialize the hash code at the beginning of the binary data. So this is a real binary data format in structpack. The first part is the hash code. The rest part is the payload. When deserialization the object, structpack will parse the hash code from binary data and generate the hash code by compile time reflection, and then compare the two hash code to finish type checking. This kind of type checking is much more efficient than classic type checking. For example, let's do a comparison. The classic type checking is not efficient because it parse type and do type checking for every field. But reflection-based type checking only parse an integer and compare an integer only one time at the beginning. Classic type checking is frequently. Reflection-based type checking only one time, and the binary size is smaller because structpack don't save extra type information. Okay, next I will talk about how to generate hash code of an object at compile time. There are 3 steps to generate the hash code of an object. The first step, mapping each member type to a unique type ID. The second step, generate a compile time string by member's type ID. Finally, generate a compile time MD5 code from the string. Yes, this is a unique type ID. It contains fundamental types, terminal types, aggregate types. And this is the process of generate hash code of a struct at compile time. For example, this struct contains 3 kinds of type. Each type will be mapped to a unique ID and then compose the unique ID into a compile time string. Finally, generate the MD5 code from the compile time string. A more complex example here. This struct contains a map, and the idea is the same. Mapping type to unique type ID. Compose the type ID into a compile time string and generate MD5 code at compile time. And this example shows a listed object. The idea is similar. Yeah. After we get the hash code at compile time, we will serialize the hash code at the beginning of the binary data here, and then serialize the object. Yes, this is the binary data of an object in structpack. Now this part we will optimize performance continuous, because we can do better when the serialized object is trivial copy object and memory continuous containers. For example, there is an object. In classic serialization, we need 6 times memory copy, right? But in structpack, only one time memory copy, because it is trivial copy object, so it only need one time memory copy. Yes, and this kind of serialization is much faster, right? And this example to show how to serialize a vector rect. Yes, the rect is also a trivial copy object, and the vector rect is a memory continuous container, so it can be optimized. In classic serialization, you need more than 8 times memory copy. In structpack, if the type is continuous containers, we can memory the whole data. Yes, the first memory copy is packet size. The second memory copy is memory copy the whole data of the vector. So it only need 2 times memory copy. It's much more efficient than classic serialization. I will show you the benchmark result at the end of the session. Now let's consider the backward compatible. Here there is an object. The object contains 2 fields. Sometimes later we need add 2 more fields. And the user hope structpack can deserialize person and a new person at the same time. In other words, how to keep backward compatible. The basic idea is use a special type, compatible type, to keep backward compatible. And the compatible type only at the tail of the object. And when generate the compile time hash code, we will ignore the compatible type. So the type code of person and the new person are the same. And this is the basic idea. Yeah. Of course, we also need to check the position of compatible type, because it is only allowed at the end of the struct. Okay, this is the last part. Yeah. I test three. I provide three test cases. The first case, we test a simple object. Here there is an object person. It is very simple, and we serialize and deserialize 1 person and 20 person. The benchmark result shows structpack is much more faster than protobuf. Yes, 10 to 20 times faster. Yes, because we don't save extra type information and don't do extra type checking or type parsing for every field. The second case, I tested a more complex object. The object contains some other object and contains more fields. Let's look at the result. Of course, structpack is still much more faster. Deserialize more than 20 times faster than protobuf. The last case, I tested trivial copy object. I mentioned before, trivial copyable object and memory continuous container can be optimized. Yes, because trivial copy objects only need one time memory copy. Don't need serialize each field one by one. This and the benchmark results show it is more than 100 times faster.